Today we are going to start with the nuclear technology, and one of the most important topic of the nuclear technology for the UPSC CSE that we are going to study in a different way that have not been taught in the entire industry. And when you will be seeing when you will cover this entire topic, then you will yourself will be able to decide that this was quite different. There is one thing to study the nuclear technology or entire science and technology. In the name of nuclear technology, the people will teach you that this is the atom, how this thing works. But here the philosophy is completely different, because right now the UPSC is not asking that kind of question. Here there might be many essays. So if we are covering some topic, so we should cover that topic from the complete basics, and we should go towards the upmost level where we can go. And in the nuclear technology itself, when we start with the nuclear technology, we always talk about if this pen is there, suppose this pen is there, the question will be there that by this thing this pen is made up of, किस चीज से ये पेन मिलके बना हुआ है, ये हमेशा क्वेश्चन होगा. और then someone will answer that this pen is made up of the matter. Then the next question will be there that by this thing this matter is made up of. And this is not the new question. This answer is being discovered by the philosophers, by the scientists from the millenniums. So let's go back to that millennia, and we will cover the topic of the essay with this nuclear technology also. Here how, when we will be covering the discovery of the atom, then parallelly we are going to cover some essays like Dalton is the man of the science. Like tradition and modernity, they are not the enemy of each other, they go hand in hand. We are going to cover these essay along with the nuclear technology. And in the UPSC, there is one thing that we cannot study any subject in the isolation. No, we cannot. It is not possible, because in the examination it is not written that this is the question of geography, this is the question of science and technology, and you have to write only the science and technology. In the science, in the paper of the ethics, he is asking the ethical principles of the biotechnology. And now the teacher of the ethics is not going to teach you the biotechnology. So here our idea is that we should study the subject in the comprehensive level, so that we can take the things from the paper 1, from the paper 2, from the paper 3 and paper 4. Then only the classes will be comprehensive. This is the idea. And in this class I am not going to dictate you the notes, because notes, you will get the notes in your drive. So we are not going to dictate the notes. Each and every note and each and every word that I am going to speak here, that will be in the notes. And here I am using a PPT to make this class more and more interactive, so that you can understand those principles of the science very easily. Because there are many of the students among us, they think that we are from the humanity, and this science is, we are not going to understand this science very much properly. The problem is that if you are going to be taught like that, taught like the easiest way possible, then science is nothing. It is just the history of science that we are going to study here. We are not going to derive the equations. So please be with me here. Today we are going to discuss 2 essays and a good chunk of the nuclear technology. So the question that I started, by which this pen is made up of. So we are going to answer that thing, that by which this pen is made up of. Now what happened? In the 16th century BC, in the India, there was a sage, Maharishi Kanad. Now Maharishi Kanad was a philosopher, and he established a school of philosophy out of the 6th school of philosophy. He was the founder of the Vaiseshik school of philosophy, and he is thinking that by which things this matter is made up of. Now after thinking, and he was thinking that till which limit I can cut the atom. Now he is thinking, and he got the idea that there will be a limit after which I cannot cut the atom. So Maharishi Kanad told that unit as Anu, that Anu is tiny and indivisible particles by which every matter is made up of. And in the same time, in the 4th century BCE, in the Greece, thousands of kilometers away, but integrated with the thing that is called the curiosity. Just curiosity. There was the integration of the curiosity. There was a philosopher, Democritus, and Democritus is thinking, and Democritus is also thinking that by which limit I can cut the atom. Then Democritus came with the idea that there will be a limit after which I cannot cut the substance into 2 equal parts. He called this substance as atomos, and atomos means in the Greece uncuttable. Atomos means uncuttable, after which you cannot cut the substance, you cannot cut anything. Then he gave the next idea. For the movement of this atomos, we need the void. We need the void. Void, it means empty space. It means we need the vacuum. And at the same time, there was a great philosopher in Greece, Aristotle. Aristotle was listening all of these things, what Democritus was telling. Then Aristotle refused all the ideas that were given by the Democritus. Then Aristotle gave his ideas that what these things are, if there is anything like atom or not. Then Aristotle gave the idea that each and every matter, every substance is made up of the 4 things. One is fire, another is air, then we have the earth, and we have the water. These 4 things, they make everything in the earth, and earth is in the center of universe. Earth is in the center of universe. He denied the theory of atom. How he denied the theory of atom? Firstly, Aristotle said that Mr. Democritus, you are saying that we need the vacuum. We need the vacuum for the movement of the atom. Then Aristotle gave an analogy. When you are running in the ground, your speed is fast, but when you will enter into the water, your speed will be slow, because this is a matter of the density. The more will be the density, the less will be the speed. The less will be the density, the more will be the speed. And if there will be vacuum, then the speed will be infinite. And this is the absurdity. Nothing in the universe can travel with the infinite speed. So Aristotle said that nature abhors vacuum. Aristotle said that nature abhors vacuum. And for the Democritus, it was a defeat. When there cannot be vacuum, then there cannot be movement of the atom. And when there cannot be the movement of the atom, then there cannot be any substance, there cannot be any matter. Then Aristotle said, the thing that you are saying, that atom are uncuttable. So Aristotle gave the principle of the continuous universe. Continuous universe, in which he said that each and everything has the purpose. Each and everything has the purpose. So this was the purposeful universe of the Aristotle. Then Aristotle said that now let me tell you how each and everything is made up of these 4 elements. Here we have the water. The property of the water is wet and cold. Then we have the air. The property of the air is wet and dry. The property of the air is wet and warm. Then we have the fire. It is dry and warm. Then we have the earth. The property of the earth is wet and the property of the earth is cold and dry. Then the question was asked to Aristotle, okay, explain this. Then Aristotle took the example. If you are burning, suppose you are burning a wood, and when you are burning a wood, then what is happening? When you are burning the wood, the fire of the wood is going upward. Fire of the wood is going upward. And why fire of the wood is going upward? Because it is the nature of the fire that it goes to upward. Then you have the smoke, and that smoke is the air, and that is also going upward. Then where is the water? The hissing sound, when you burn the wood, you listen a hissing sound, and that hissing sound is because of the water droplets, that is the liquid on that. So because of that water is turning into the air because of the fire, and the remains, that is the ash, that will always remain in the earth. And the nature of the ash or the nature of the earth is always remain in the center of the universe. That is why if anything that will have the mass, that will always come back towards the earth, because each and everything want to go towards the earth. Now this philosophy of Aristotle or Aristotle, each and every person in the world, he was able to relate it. He was able to see the evidences that was given by the Aristotle, and whatever was said by the Democritus, he was not able to prove those things. And what happened? Then in the European science, in the level of the atom, in the field of the atom, there was complete silence for the next 2000 years. Because after the Aristotle, there will be the emergence of the church, and the philosophy of the Aristotle, that purposive universe, it was well aligned with the theology. So with the support of the church, the idea of the Aristotle prevailed for the next 2000 years. Then there will be a person named John Dalton. Then there will be a person, Mr. Dalton will come, and Dalton will turn this philosophy into the science. But main मुद्दा क्या है यहाँ पे? What we need to learn here, that something was said by Aristotle, but that thing, whatever was told by the Aristotle, that thing hindered the development of science for the next 2000 years. And after 2000 years, in 1808, John Dalton will come, and he will prove that scientifically that there are atoms. Okay, that is a thing. That is a thing. Now, what point we want to make here? Doubter is the man of the science, because John Dalton doubted on the idea of the Aristotle, of the continuous universe, of the absence of the vacuum, and he proved it, that yes, there is atom. he would not have doubted on the idea of the Arastu that prevailed for the 2000 years, then whatever discovery in the field of the nuclear science we are seeing right now, that would not have been possible. Now, not only the doubter, let me tell you some story firstly, then we will move towards the science of the atom. Who doubted? On the idea of the Arastu, Dalton doubted. He discovered the atom. Then he said that atom is the fundamental unit of each and everything. Then Mr. J.J. Thomson came. Then Mr. Thomson came. He performed eye experiment using the cathode ray. He discovered the electron. And he gave the plum pudding model. Then when he discovered the electron, then Mr. Rutherford came, Lord Rutherford, and Rutherford doubted that it is not like that, plum pudding don't work like that, atom don't work like that, and he discovered the nucleus, and then he discovered the proton. And Rutherford gave the solar system model for the atomic theory. Then Niels Bohr came. Niels Bohr doubted on the idea on the solar system model, and he gave the quantum orbits. Then Heisenberg came. Heisenberg said, sir, you are saying these are the particles. No, sir, these are not the particles, and they don't orbit. These are the electron waves, and they remain in the cloud of the nucleus. And this thing is acceptable till the date. But what is the reality? Till the date, we are able to give only the partial answer for the atomic theory, that what is in the atom and how it works. So here each and everyone doubted. So in the science it is said that skepticism, the person who is skeptic, is not the hindrance in the science, but skepticism is the science. It is the development of the science. So this can be another essay, because on the idea of the Aristotle, Dalton did the skepticism, then so on. Then the next thing we are going to discuss about the atom and what was proposed by Dalton. Now in 1808, Dalton was a very good chemist. In 1808, what Dalton gave two principles to define the theory of the atom. The first principle he gave, that law of the conservation of the mass. He said that mass can neither be destroyed nor be created before or after the chemical reaction. Means if you have 8 gram of the milk and 8 gram of the coffee, and if you will mix that, there will be chemical reaction and you will get 16 gram of the mixture. The mass will neither be created nor be destroyed in the chemical reaction. Then he gave second law, the law of the equal proportion, or the law of the definite proportion. As per the law of the definite proportion, what happens? Let's take the molecule of water. Suppose you have 8 atoms. You have 8 atoms of hydrogen and 8 atoms of oxygen. Then how many water molecules you will have? Because to make one water molecule, we need 2 hydrogen and 1 oxygen and 1 molecule of one atom of oxygen. So by this we will have 4 molecules of water. There will be 4 to the 8. The 8 hydrogen atom will be exhausted. And it will use only 4 oxygen atom. So this is how you will have only 4 water molecules and 4 oxygen atoms will be remained. And Wherever you find the water, the same principle will be applied. You find the water in the earth crust, you find the water in the water vapor, you find the water in your kitchen, everywhere H2O will be H2, water will be water, and that water will be composed of 2 hydrogen and 1 oxygen element. So this is the law of definite proportion that was given by John Dalton, and he explained this theory that atom is the fundamental unit. Then comes the J.J. Thomson. At that time, the idea of the cathode ray was very fascinating idea. It was very fascinating. J.J. Thomson was performing the experiment using the cathode ray tube, and in the cathode ray tube, here we have the cathode. Here we have the cathode that is negatively charged cathode we have, and another side we have anode that is positively charged, and we will connect this cathode ray with a battery, and here when we will connect this cathode ray with battery, and inside the cathode ray there will be low pressure, when we will connect it with the battery, there will be a glow, like we can see this, there will be a glow in the cathode ray, in the cathode tube, and no one was able to decipher that what this glow is. Then J.J. Thomson came and he put positive and negative charge, one positive plate on the upper side and negative plate on the lower side, and there was famous electromagnetic principle that positive and positive, they will repel each other, positive and negative, they will attract each other. So Mr. Thomson saw that this cathode ray is tilting towards the positive plate. When it is tilting towards the positive plate, it means it is negatively charged, and he named it that these are the electrons. Now we got one more thing inside the atom, that was the electron. Now the puzzle was that atoms are positive charge, atoms have the positive charge, and this electron is negatively charged. Sorry, atom is neutral, not positive. This atom is neutral. Now these electrons that Thomson got, they are the positively charged, sorry, they are the negatively charged, and atom is neutral. Now to make the atom neutral, we need some positive charge. When positive and negative will meet, then only we will have the neutral substance. So that is why, to explain this model, he gave a model that is called the plum pudding model. In the plum pudding model, what Thomson described, that these are the negative electrons, like the plums in the pudding. Or you can say, if you have seen the watermelon, in the watermelon, inside the watermelon we have the red pulp, and we have some brown and black color of the seeds. So that red pulp of the watermelon, consider it as the positive charge, and that black seeds, here they are equivalent to the electron, they are negatively charged, and this positive and negative, that makes the atom neutral. And he was doing all of these things in 1897. Now next scientist, Lord Rutherford. Now there will be entry of Lord Rutherford. Ab he was not able to believe that plum pudding model is correct and we don't have any other thing inside the atom. So he performed the gold foil experiment, the famous gold foil experiment. He took the gold foil, this is the gold foil, and here he took the helium nucleus, or you can say alpha particle. He took the alpha particle, and this helium nucleus, this is positively charged, nucleus is positively charged, or you can say alpha particle is positively charged, and he was firing these alpha particles on this gold foil. Then what he observed is some of the alpha particles, they pass straightly, and some of the alpha particles, they deflected like this. You can see this yellow one, it is deflecting, and this green one, it is passing straight. Then this pink one, it is bouncing back. So here it means, here where this pink one is bouncing back, here there is very solid substance, very solid inside the nucleus. So now he concluded that most of the atom is empty. What he concluded? Most of the atom is empty, and in the very center of the atom we have the entire mass. In the very center of the atom we have the entire mass, and that is very dense. That is very dense. Now he proposed that this nucleus is positively charged because it is deflecting the alpha particle. So when he proposed that nucleus is positively charged, he came with a new model that was described by him, and his model is called the solar system model. Now what is this solar system model? Like in the solar system, in the center we have the sun, and every planet and every other body of the solar system, it orbit around the sun. And can you tell me whether sun is stationary or it is also orbiting something? If you know, you can give me the answer whether sun is stationary or it is also orbiting something. Let me tell you, sun is orbiting in a very, very fast speed around the central black hole of the Milky Way, and that have the mass of approximately 4.2 billion suns. Sun बहुत छोटा है उसके आगे. 4.2 billion suns of the mass that is Sagittarius A, the central black hole of the Milky Way, around which sun is orbiting. Are we clear? Now he gave the solar system model that nucleus is in the center, and around the nucleus electrons are orbiting. Nucleus is positive and electrons are negative, that is why the atom is neutron. Okay. Now there was a problem, but at that time there was a scientist, Maxwell. Maxwell gave a principle that if any charged particle will orbit or move, it will emit energy. Whenever charged particle will orbit in a particular orbit, it will emit energy. Like when this charged particle is moving, electron is charged particle, negative charge है उसके पास. When this negatively charged electron will move, it will emit some energy, and when it will lose the energy, there will be a day it will crash into the nucleus. And when this electron will crash into the nucleus, then there will be no atom. But it is not like that, it is not happening. We have the atoms, and with the atoms this universe is made up of. So we have the example in front of us that these electrons are not crashing. It means solar system model is not working. That was explained by Lord Rutherford. Then in 1917 he discovered the proton. Then in 1917 Rutherford discovered the proton. But before that, to explain this model of the atom, Niels Bohr came. And what Bohr said कि देखो sir, there is one thing, कि here don't apply in the atom, in the structure of the atom, don't apply the classical physics, because classical physics does not work in these tiny spaces, in these tiny things. Here, which will work? What will work? Here quantum physics will work. Because at the level of the classical physics, when the charged particle will orbit, then it will radiate the energy, it will lose the energy, and it will crash down on the nucleus. But as per the quantum mechanics, these electrons, they move on the fixed orbit. These orbits are fixed, and these electrons are moving in the fixed orbit. And when these electrons are orbiting in the fixed orbit, they are not losing energy, no loss of energy. When these electrons are moving in the fixed orbits, they are not losing energy. Then the question was asked, sir, you gave 4-5 orbits, in which orbit which type of electron will move? Then Niels Bohr answered that, sir, here the lowest energy, here we will have the highest energy. It depends how much energy the electron have. If the electron have the lowest energy, it will orbit in the in this orbit, the closest orbit to the nucleus, and if it have the highest energy, it will orbit in the farthest orbit of the nucleus. Then there was another thing. The question was asked, if I can increase the energy of this electron which is moving in this, if I gave some energy, then yes, it will absorb the energy and it will jump into the next orbit. And again I gave some energy, it will jump into the next orbit. And then again, if I will give some energy, it will leave the orbit. Depends on the energy. But when it will try to come back to its parent orbit, what will happen? Then this will happen. When it will try to come back on the parent orbit, then it will lose the energy. Then what will happen? Then it will lose the energy like that. It is losing the energy when it is going to the parent orbit. And this is how we will see the emission of the light, the different color of the light. Up suppose this electron is moving from this orbit to this orbit, outermost to the innermost orbit, then the color of the light will be different. It means the frequency of the light will be different. And when it is moving from this orbit to this orbit, then the frequency will be different. It means there will be difference in the energy. There will be difference in energy. When there will be difference in energy, then there will be change in the color of the light. And the same principle worked for the photoelectric effect. With the same principle, Einstein will derive the photoelectric effect. And you know, for the photoelectric effect, Einstein got the Nobel Prize, and he shared the Nobel Prize with the Niels Bohr, because this principle was defined by the Niels Bohr. So Einstein shared his Nobel Prize of the photoelectric effect with the Niels Bohr. And you know that Einstein gave the theory of relativity. For that he never got the Nobel Prize. He got the Nobel Prize for the photoelectric effect. Now we have the protons, we have the nucleus, we have protons and nucleus. But you know that there is something that is called neutral Till the time we are only thinking here, till the time we know only that here we have something with the protons, that have approximately same weight with the protons till the time the neutron is not discovered. So the model is like that. We have the nucleus, in the nucleus we have the positive, in the nucleus we have the protons, and this nucleus is positively charged, and we have the electrons, negative electrons, and they are moving around the nucleus in the fixed orbit as per the law of the quantum mechanics, and when they are orbiting the nucleus they are not losing the energy. This thing we have till the time. Now there will be a scientist, he will come, Heisenberg, and Heisenberg will give the principle of the uncertainty. Heisenberg said, sir, you can either know the location of the electron, or you can know the momentum of the electron or speed of the electron, but simultaneously you cannot know both of these things, and this is called the Heisenberg uncertainty. And the modern physics that we are working right now, it is based on the Heisenberg uncertainty. Each and everything that we are working right now is based on the Heisenberg uncertainty. Okay, then next, then there will be a scientist named Schrödinger. Now Schrödinger will come. Now Schrödinger said कि sir, you are saying that electrons are particle. इसके पहले डी ब्रोगली आए, डी ब्रोगली ने बताया कि that electrons are wave also. तो अभी उसमें बहुत डिटेल में नहीं जाना है मैं. तो after the de Broglie, Schrödinger will say कि you are saying that electron are moving in the fixed orbit. No sir, it is not like that. It is not like that. Electrons are wave, and there are clouds around the nucleus, and for which things you are saying orbit, that thing is the their location, their probability, their maximum probability where we can find the electrons. पहले तो श्रोडिंगर बोलते हैं कि that they are not the particle, they are the wave, and when you observe then they behave like the particle, they are the wave, and when you observe they behave like a particle. Okay, so this is model of the Schrödinger that is accepted right now, that there is cloud of the electrons. Now instead of orbit we have the orbitals. These are the Schrödinger orbitals. Instead of orbit we have the orbitals. Till the time we don't know the neutron, and at the same time there was a question that was asked to the Einstein, that whether we can split the atom. Einstein said, how we can split the atom? We don't have anything. Because how you will split the atom? You know the proton is positively charged, nucleus is positively charged, and when you will hit the nucleus with the proton, what will happen? When you are hitting with the positive charge, then it will repel. Instead of hitting, it will repel each other. And at that time Einstein said that we don't have anything which can generate that much of the energy and hit the nucleus and split it into the two, because we did not know about the neutron. Now with the discovery of the neutron, each and everything will be changed, and there will become the era of the human drama, and that will change each and everything. Now before going towards that, we need to know about the isotopes. Now what are these isotopes? Then we will go towards the example. We learned about the atom, atomic structure. Now we need to know about the isotopes. So what are these isotopes? In the isotope, what happens? The first rule, there will be same number of the proton. There will be same number of protons, and their atomic mass, it will be different. Their atomic mass will be different. Same number of the protons and atomic mass will be different. and you know that the element is decided by the proton. Which element it is? It is decided by the proton. And if there will be same number of the protons, it means it will be the same element. It means it will be the same element, but atomic mass is different. So it is kind of two siblings of the same father or same parents. There will be same number of the protons. It means there will be same element. Now, let us see one thing. If we have the same number of the proton, suppose we have the 6 protons, then to make it neutral, it will have 6 electrons, because proton is positively 1 charge, proton is positive 1, electron is negative 1. To make this atom neutral, we need the 6 electrons. Okay. Now let us take the example of certain isotopes, like the isotope of the hydrogen. 1H1, this is 1H1, that is protium. In the protium we have 1 proton and 0 neutron. Then we have 1H2, that is deuterium. In the deuterium we have 1 proton and 1 neutron. Then we have tritium, 1H3. We have tritium, 1H3, that have 1 proton and 2 neutrons. Now let us understand certain other things, that we got to know that this is the proton. Then what is the atomic number and atomic mass? We need to know also these things. Then atomic mass is equal to number of proton and atomic mass is equal to addition of number of proton and number of neutron inside the nucleus. And what is atomic number? Atomic number, it is number of proton in the nucleus. So either you can say the number of the protons or you can say number of atomic number. That is the same thing, because atomic number is number of the protons in the nucleus. Then what is atomic mass? Atomic mass is number of the proton and neutron, the addition of the number of proton and neutron in the nucleus, that is the atomic mass. Because most of the mass of the atom resides in the nucleus, and in the nucleus we have the proton and neutron. Okay. So here we saw the isotope of the hydrogen. Here what is the atomic mass? Here it have only 1 proton, 0 neutron. So atomic mass of the protium is 1. Atomic mass, in the same way, atomic mass of the deuterium is 2. In the same way, atomic mass of the tritium is 3. How? 1 proton, 1 neutron, 2. 1 proton, 2 neutron. Atomic mass is 3. Now you will say, sir, if hydrogen have the two protons, then sir, hydrogen will never have the 2 protons. It will change into the helium if there will be 2 protons, because the element is decided by the atomic number, or you can say proton. Okay, we can understand this thing, that element is being decided by the atomic number or protons. Okay, if there will be one atomic number or 1 proton, that element will be hydrogen. 2, then helium. 3, then lithium, and so on. As soon as the number of the proton will increase, what will happen? The element will change. Okay, this thing we understood, that these are the isotopes. And where we use the protium? Protium is your normal water that we use in the daily basis. Then we have the deuterium. Deuterium, we use the deuterium as the heavy water for the purpose of the moderator, and sometimes as coolant in the nuclear reactors. Then where we use the tritium, tritium is radioactive, and we will use the tritium in the nuclear फ्यूजन, नाभिकीय संलयन, न्यूक्लियर फ्यूजन में हम ट्राइशियम का यूज करेंगे। कहां पे? आईटीआर, कहां पे? आईटीआर या फिर for the purpose of the nuclear fusion that is going on in the core of the stars. It is using the tritium. So these are the use of the isotopes. Then let us see some most important geopolitical isotopes. These are very common. Then can you tell me the most important geopolitical isotope? One of the most important geopolitical isotope? Yes. Yes, this is uranium. This is uranium. Geopolitically most important isotope. One of the most important isotope. So uranium, we find uranium in the many isotopes of the uranium are being found. But which isotopes of the uranium are important for us, which naturally occur? That is uranium-238 and uranium-235. When we mine this uranium in any mines, be it in Jadugoda, Tugnapalli in the India, the natural composition of the uranium will be natural composition of the uranium U-235 we will have 0.7% and U-238 will have 99.3% approximately. I am saying it approximately, not exactly. Approximately 99.3% and अब इसको कैसे हटाएं देखते हैं हट गया. We will have approximately 99.3% of the uranium-238. So this is the isotope of the uranium, of which uranium-238 is fertile and uranium-235 is fissile. Fertile, it means it will not undergo fission, but it will convert into the fissile. Fissile, it means it will undergo the fission, it will break down. अभी उसकी बात हम थोड़ी देर बात करेंगे. We will talk about that just after some time. Now we got to know that in the isotopes, when we were studying about the isotope, we got to know that the number of the proton will be same and atomic mass will be different. This thing we got to know. Now let us apply this thing in uranium. Here we have 92 protons. In the uranium we have 92 protons and 146 neutrons in 238. In 235 we have 92 protons and 143 neutrons. Now what is happening, what I want to show you, that here we have the proton-neutron ratio. Here we have the proton-neutron ratio. And this proton-neutron ratio makes the atom radioactive. If this proton-neutron ratio is not balanced, then that thing will be radioactive. We saw on the tritium that this is 1s3 here, number of the proton is 1 and number of the neutron are 2. It means we have the more number of the neutron. And for in general understanding, instead of going in the depth of the neutron-proton ratio, that is not important for the UPSC, we should understand in general understanding that if neutrons are more than proton or protons are more than neutron in smaller elements, what happens? If this thing happens, then this thing will be unstable. This nucleus will be unstable, and this unstable nucleus, it will cause the process of the radioactivity. It will cause the process of the decay, radio decay, or you can say nuclear because neutron and proton ratio is not balanced, because of which we will have the radio decay or you can say radioactivity. And now why we have the radioactivity? सबसे बड़ा कारण क्या है? आखिर radioactivity क्यों? What is the reason for the radioactivity? Now let us see the reason for the radioactivity. Let us see the reason for the radioactivity. Each and everything in this universe want to achieve the stability, to become stable. These particles where neutron proton ratio is not balanced, what will happen? They will emit something, they will emit some mass, or they will emit some energy. So by emitting some mass or some energy, they will try to retain the stability so that they can remain stable. Like you are studying and you want to remain stable, that is why you are studying. You want to make your career stable, to become IAS officer or IPS officer, that is why you are studying. If not, so you also want to remain stable. In the same way, in the entire universe, each and everything want to remain stable. Each and everything want to remain stable and want to achieve the stability. Now, to achieve the stability, these particles, these unstable nucleuses, they will emit something, either some particle or some wave. Now, let us see which type of particles or waves or rays are being emitted in the process to become stable, in the process of the radioactivity. And these type of elements which are unstable, they are also called the radioisotopes. They are also called the radioisotopes because they are emitting something. It will emit the alpha particle. Alpha particle is nothing but the doubly charged helium nucleus. Doubly charged helium nucleus. This is what? 2He4. It is nothing. Then beta minus. Emission of beta minus, it means emission of electron. Then beta plus, it means emission of positron. Then gamma, this is the pure energy. These are particles, alpha, beta, and gamma is pure form of energy. Now, separately, we should see separately these emissions, like where we can use the alpha emission, where we can use the beta, and where we can use the gamma. Now see, this is the alpha particle decay or radioactive decay, you can call it. लिख देता हूं मैं. This is radioactive decay. This is radioactive decay or radio decay. And here this radioactive decay is happening in the form of the emission of the alpha particle. This is the nucleus of the uranium-238, where we have 92 protons and 146 neutrons. And I told you that in the alpha particle, what we have in the alpha particle, I told you that in the alpha particle we have doubly charged helium nucleus. When in the alpha particle we have the doubly charged helium nucleus, what is happening? What is being emitted here? Here 2 neutrons and 2 protons, 2 neutrons and 2 protons are being emitted. For the helium, in the nucleus of the helium we have the 2 neutrons and 2 protons, and because it has the 2 protons, that is why it is the helium. And when helium nucleus is being emitted from the uranium-238, so it will lose its proton number by 2 and it will lose its neutron number by 2. So what will happen? Next element, what it will become? It will become the thorium-234, because there will be loss. There will be loss of what? There will be loss of 2He4. From the atomic mass there will be loss of the 4, and from the atomic number, that is proton, there will be loss of the 2. When this will happen, then what is happening? It became the thorium-234. Yes, 90 proton for any element, that is called the thorium. Now next is very interesting and very important for us. this is the alpha decay of the plutonium-238. What happens in the alpha decay of the plutonium-238? There will be release of doubly charged helium nucleus, or you can say alpha particle. When it will happen, then this plutonium, when this will happen, with this there will be some release of heat, and this heat will be used by the thermocapsule, and this thermocapsule is installed into the radioisotope thermoelectric generator in the RTGs. This thermocapsule is installed into the radioisotope thermoelectric generator. Because of this heat, this thermocapsule, it will convert this heat into the power, that is electricity. And where we will use this electricity? We will use this electricity in the space probes. Like there is a space probe, that is Voyager 1 and Voyager 2. They were sent to the space in approximately 1977. In 1977, and till the date, today we are in 2026, and I think in 1977, the Voyager spacecraft were sent to the space. Now, till the date, we are approximately going to touch 50 years because of the radioisotope thermoelectric generator, and that is using plutonium-238 as the fuel. They are still communicating with the NASA. This Voyager 1 and Voyager 2, they are the spacecraft of the NASA. And the very interesting thing about the Voyager is, that this Voyager spacecraft, this Voyager 1, it crossed the solar system in 2012, and Voyager 2, it crossed the solar system in 2018. Please give me a moment. This Voyager 1 and Voyager 2. So, this Voyager 1, it crossed the solar system in 2012, and Voyager 2 crossed the solar system in 2018. Now, why it is important? It means these are the only man-made spacecraft, only man-made things who have crossed the solar system. And what is the meaning of crossing the solar system? The meaning of the crossing the solar system is that they have crossed the heliopause. Right now they are in the interstellar space. Interstellar space, it means the space between the two stars. That is one star, that is sun. And can you answer me the nearest star system nearby the sun? The nearest. क्या आप अपने पड़ोसी को जानते हैं? Do you know your neighbor? Which star is the neighbor of the sun? The nearest neighbor of the sun. And let me tell you, on that star system, there is not single star, there are 3 stars. That is triple star system. Now can you answer? That is Proxima Centauri. That is Proxima Centauri. On that star system, we have 3 stars: Proxima Centauri A, Alpha Centauri A, Alpha Centauri B. Okay. So this Voyager 1 and Voyager 2, they are in the interstellar space. Now, in the upcoming month, that is November 2026 or December 2026, Voyager 1 is going to achieve the historical milestone. And this historical milestone, this Voyager 1, it will be away from us 1 light day. 1 light day. 1 light day, it means when light will take 1 entire day to reach the Earth from the Voyager 1, and light travel with the speed of approximately 3 lakh kilometer per Second, with this speed light travels, and with this speed, when light will be emitted by the Voyager 1, it will reach to the earth in 24 hours. That is one light day. It means light will take 1 day to reach to the earth from the Voyager 1. And why it is important? This will be the historical milestone for the mankind. This is the first time any man-made thing will reach that far from us, that it will cross the limit of the 1 light day. Okay, it means what it means 1 light day, what it means, the meaning of 1 light day, when the Voyager 1 will send the signal towards us, and that signal will be in the electromagnetic wave, so that signal will reach to us after 1 day, after 24 hours. And when we will be sending any direction, any signal to the Voyager, it will take 24 hours to reach the Voyager. It means for even a smallest communication with the Voyager after November 2026, we will be taking 2 days. 1 day to reach the signal, another day the respond by the Voyager. Okay. Not only Voyager, these deep space missions usually use RTGs, radioisotope thermoelectric generator, and the fuel will be the plutonium-238. Like in the Mars, we have right now we have 2 working rover of the America. One is Curiosity, another is Perseverance rover. And Curiosity went a decade back. Perseverance they sent on the 2020. So Curiosity and Perseverance, they both are working right now till the date, because they are using radioisotope thermoelectric generator. Now there was another mission of NASA towards the Pluto, that was New Horizon mission. The only single mission that have went to the Pluto, the New Horizon mission. It was also using radioisotope thermoelectric generator and plutonium-238 as the fuel. So this was alpha decay. Now I think you are clear about the application of the alpha decay. We can use this alpha decay in the process of the radioisotope thermoelectric generator for the spacecraft. Now we have the beta decay, and we have the many application, plethora of the application of the beta decay. And what happens, why beta decay happens? When there will be more number of neutron than the proton in the nucleus, then to achieve the stability, this neutron will try to convert into the proton. When this neutron will try to convert into the proton, because it want to achieve the stability. When this neutron will try to convert on the proton to try to achieve the stability, then what will happen? Then there will be emission of the electron, and electron को ही हम बीटा माइनस पार्टिकल बोलते हैं. बीटा पार्टिकल का मीन्स इज नथिंग बट द एमिशन ऑफ द इलेक्ट्रॉन. सो दिस इज द बीटा decay. Then there is fluorine 18. When fluorine 18 converts into the oxygen 18, then here जब fluorine 18 convert होता है oxygen 18 में, here one proton will convert into the one neutron, and this is beta plus decay. This is beta plus decay. In the beta plus decay, what emits? Positron. Positron. It means it is the anti-particle of the electron. Electron have the negative charge, positron have the positive charge, and this positron is used into the PET scan of the body. So these are the medical applications of the beta decay. Now we have the gamma decay. Gamma is a ray. Alpha and beta were the particles and gamma is the ray. Now take technetium-99m, and technetium-99m, it is a radioactive and it releases gamma, and its half-life is only 6 hours. So because of which it is releasing gamma rays as the energy. Because its half-life is very less, we use technetium-99 for the internal for the internal imaging of the organs, internal 2D or 3D imaging of organs. Whenever you have to do this internal imaging of the organ of the body, then what they will do, they will give some capsule to the patient, and that capsule will have technetium 99m, and when that capsule will travel into the blood vessels in the blood, then that will release some gamma rays, and using those gamma rays, the computer what it will do, it will capture very clear 2D and 3D images of the internal organ of the body. Not only this, now let's take, instead of technetium, we are taking cobalt. Cobalt also emit the gamma ray. We use the cobalt for the treatment of the cancer. Gamma ray have the energy, and gamma ray can kill the cancer cell. So we are using cobalt in the radiotherapy. Not only in the radiotherapy, we can use these gamma ray for the purpose of mutagenic crop, because gamma ray have the energy. They will cause the mutation in the DNA. When they will cause the mutation in the DNA, then we will have the mutagenic crops. And Bark is doing research on the mutagenic crop. It is different from the genetic edited crops. In the genetic edited crops, we do the precise editing, but here we have the hit and miss. We have the hit and miss. We can get the good crop or the bad crop. If there will be bad seed, we will destroy that, and if there will be good seed, we will adopt that. These are the mutagenic crops. Then we can do the food irradiation, because gamma ray, suppose right now many people are doing chemical food irradiation, chemical treatment of the food. When the people are doing chemical treatment of the food, and our population is eating that food by washing the food, and sometimes the chemical remains. When the chemical remains, then there will be bioaccumulation. After some time, there will be biomagnification. Bioaccumulation, it means the entry of that harmful chemical inside the body. Biomagnification, again and again you are eating that chemical rich food, that harmful chemical rich food, then there will be biomagnification. It means the amount of that chemical, that harmful chemical will increase inside the body, and after some time it will become very lethal. Now, how to solve this problem of the chemical treatment of the food? Because if you have to do the chemical treatment into the, I think, milk, how you will do? Because you cannot wash the milk. No, you cannot. Now, how to do the chemical treatment? How to do the treatment of the milk so that the milk remain healthy for some days? Now, here we have the option for the food irradiation. We can use the gamma rays. Because any chemical that you will spray, suppose this is wheat, inside the wheat, suppose there is pest, and you are using the chemical treatment, that chemical will not enter inside the hard wheat. No, that will not enter, and pest is enjoying inside the wheat, and your chemical treatment that you are doing, that is only outside of the wheat. Now, how to kill that pest also? But gamma ray, these gamma rays, they can penetrate that surface very easily. Abhi dekhenge, in the next slide we have the penetration power of this alpha, beta and gamma particle. Gamma ray can penetrate even thick sheet of the lead and very thick sheet of the concrete also. To stop the gamma ray, we need very thick sheet of the lead and the concrete. So here we can do the chemical, we can do the irradiation of the food using the gamma ray, and gamma ray can penetrate any of the grain, any of the food. When gamma ray can penetrate any of the food, then the pest that is inside the food, that will definitely be killed, na? But by the chemical treatment, you cannot do that. And as per US FDA, this food irradiation by the gamma ray is completely safe for the consumption. And US FDA is the highest benchmark to tell us that which thing is consumable and which thing is not. So if US FDA is saying that, then we can trust on the US FDA. Now let us see the penetration power of this alpha, beta, gamma. Like alpha is a big particle, it is doubly charged helium nucleus, so its penetration capacity is less. It can be stopped by only thin sheet of the paper. एक thin sheet of the paper ने alpha को stop कर दिया. Then beta, it is electron, beta minus is electron, beta plus is positron. So it will have more penetration power. Now it will be stopped by the aluminum. And the gamma, that have the highest penetration power, it will be stopped by only thick sheet of the lead or very thick sheet of the concrete. So gamma have the highest penetration power. So this is your radioisotope decay. These are the 4 type of the decay that happens in the nucleus. Now we have the half-life. When there will be decay, it means then that element is decreasing day by day because of the decay. So here in the radioactive substances, we have the half-life. Half-life, it means there will be some time when it will remain 50% of the initial quantity, then 25% of the initial quantity, then 12.5% of the initial quantity, and so on. But it will never be zero. Because एक time पे छोटा आधा होता जाएगा. 50%, then 25%, then 12.5%, and so on. It will never be zero. So this is the concept of half-life. Half-life, it means right now if you have 10 kg of the uranium-238, if you have the 10 kg of the uranium-238, then how much time it will take for the uranium-238 to decay into the 5 kg of the uranium-238. So you know that the age of the half-life of the uranium-238 is quite high. It is 4.5 billion years. 4.5 billion years. This is the age of the earth. This is the age of earth. It means when we have the formation of earth, at that time whatever uranium was there, right now today we have just half of that uranium. That is the half-life of the uranium, and we use uranium-238 dating for the radio dating. क्यों? क्योंकि ये रेडियो आइसोटोप है. Then we have uranium-235. It has 700 million years of the half-life. When in the earth life came from water to land, that is that age, 700 million years. Then beta, we have carbon-14. That carbon-14 is the isotope of the carbon. Here we have the carbon-12, we have the carbon-14. And this carbon-14 is radioactive. This carbon-14 is radioactive. And this carbon-14, it have half-life of approximately 5300 years. So you must have heard the term carbon dating. Yes, this carbon-14 is being used in the carbon dating because when, and actually in the organic things only, because when the organic things, they they do the respiration, they take some carbon dioxide from the atmosphere, they take some food in the form of carbon from the atmosphere, then what happens? And on that carbon we have some isotopes of the carbon 14. So in the entire lifetime the organism will accumulate some carbon 14, but you know that this is radioactive, and this carbon 14 it will try to convert into the nitrogen 14 to achieve the stability. One neutron will convert into the, one neutron of this will convert into the one proton, and it will become the neutron 14. Then what will happen? After the death of the organism, this decay starts, and on every 5300 year, approximately every 5300 year, the amount of that carbon 14 will be halved. So using that, we analyze the age of the organic substances, organic fossils that we got. And there is one more thing I want to tell you here that I think I missed in the previous slides, that here you have the carbon 12 and carbon 14. In the carbon 12 you have the 6 proton, in the carbon 14 you have the 6 protons, but here in the carbon 12 you have the 6 neutrons, but in the carbon 14 how many neutrons you have? 8 neutrons. 8 neutrons you have. And we also discussed that the nucleus is, the atom is neutral. Now to make carbon 12 neutral, how many electrons will be needed? It will be 6, because we have the 6 proton, that is positive charge, 6 electron, that will be negative charge, it will make it neutral. Then we have the carbon 14, how many electrons will be needed to make this neutral? Again the answer will be 6. Again the answer will be 6, because carbon 14 also have only 6 protons, and proton govern the number of the neutron. There will be, in the atom there will be same number of the neutron, sorry, there will be same number of the proton and the electron, because proton govern the number of the electron. And yes, here in the isotope what happens? The nuclear property will be different. In the isotope there is a funda that nuclear property will be different. Nuclear property will be different, but chemical property will be same. How it will be same? Because electrons defines the chemical property, because electrons take the part in the chemical process, in the chemical reactions. So chemical property is defined by the electrons, and in the isotopes we have the same number of the electrons. So for the isotopes the chemical property will be same and nuclear property will be different. Yes. Now coming back to the half-life. I was discussing this carbon, yes, organic. I was telling you that we do the dating of the organic substances using the carbon 14. But many of the times you must have heard that we got some statue. We got some statue of something, and the age of the statue is being determined using the carbon dating. But isn't it the irony that I said that carbon dating is being used for the organic substances, but that statue is made up of the stone, and stone is not an organic thing. So how we can do the carbon dating of the stone? Actually we don't do the carbon dating of the stone. The organic things that grow nearby that stone, we do the carbon dating of that thing, some alga, some fungus, or whatever is there. We do the carbon dating of those things which are stuck nearby the stone. So this is the concept of the half-life that we have completed. Now there is very interesting thing. As soon as the neutron will come into the picture, the entire picture will be changed. Now this is the time of the story. A very story that have the complete human drama, that have the brain drain, that have the science, and this story will change the entire history of the world. And after listening this story, your complete perspective will be changed, and we will use this story in the brain drain, because in India we are facing the problem of the brain drain. Because for any nation, what is the real wealth? the real wealth of the nation is the people's brain. And you know कि when the brain drain happens, this brain drain causes the national security threat for the country, and I am going to prove that. Now there was the time 1932. James Chadwick discovered the neutron. Who is James Chadwick? James Chadwick was the student of the Rutherford. Why Rutherford? That the Rutherford who discovered the nucleus and the proton, and his student James Chadwick discovered the neutron. Rutherford also got the Nobel Prize, Chadwick also got the Nobel Prize, Niels Bohr also got the Nobel Prize, Einstein also got the Nobel Prize, disciple also got the Nobel Prize, teacher also got the Nobel Prize. In India, how many Nobel Prize we get? What was the last time when an Indian working in India got the Nobel Prize? Can someone answer that? What was the last time when an Indian working in India got the Nobel Prize in the field of the science? Here they are getting Nobel Prize. In the families, they are getting the Nobel Prize. Teacher is getting Nobel Prize, disciple is getting Nobel Prize, and after that, his disciple is also getting the Nobel Prize. Okay, so let's move on. So the right answer is C.V. Raman. In 1930s, when we were not independent, when we were the colony of the Britain, then an Indian, Mr. C.V. Raman, got the Nobel Prize working in India. Okay, so let's move forward. Rutherford, he discovered the neutron in 1932, and for the discovery of the neutron, and this neutron was the neutral particle. This neutron was the neutral particle. Now the problem solved. That when we were hitting the proton or the alpha particle, they both of them positive. When we were hitting this into the nucleus, then what was happening? This nucleus was also positive and it was repelling. Now we got the bullet to hit the nucleus. Now first time we got the bullet to hit the nucleus, because now we know about the neutron, thank God, because of the Chadwick. What happens? So then when Chadwick published this paper, that paper was read by Enrico Fermi, and Enrico Fermi, he used to live in Italy. Wait for a minute. Enrico Fermi used to live in Italy. Now, what is happening? Now he got to know, Enrico Fermi got to know that we have the neutrons and neutrons are neutral. So they got the bullet to hit the nucleus. Enrico Fermi took the uranium. He took the uranium and he started hitting this uranium with the neutrons, and he was doing the experiment. And what happened? Something new came up. Now Fermi thought he have discovered and he have made the trans uranium element. It means the element that is bigger than the uranium. The element that is bigger than the uranium. Right now we know that element is neptunium, but abhi to pata nahi hai Fermi ko. So Fermi published this paper that he have discovered the trans uranium element. Uranium से भी बड़ा element Fermi ने discover कर दिया, and world clapped, everyone clapped. Then what happened? And this is, can you tell me that there was Nobel Prize that was awarded for that discovery? That never happened. The Nobel Prize was awarded for a wrong discovery, and that Nobel Prize was for the Fermi. 1938, what happens? In the 1938, Fermi was awarded the Nobel Prize for this trans uranium element. अभी बताएंगे कि what was this element. Just wait for a second. Now, when he was awarded the Nobel Prize in 1938, and right now the Mussolini had the very strong hold in the Italy in 1838, and he had some oppressive laws for the Jews. But Fermi was not the Jews. Fermi's wife Laura was Jews, and Fermi had the two children. Up now, Fermi was thinking ki how to save the life of my family. What happened? Fermi requested Mussolini. He said, I got the Nobel Prize and I have to go to receive the Nobel Prize, and I want that I should accompany with my family. But this never happened. This never happened. Before that, none of the scientist's family accompanied that scientist to receive the Nobel Prize. But Fermi had only one chance, somehow to pursue the Mussolini. Then Fermi requested Mussolini by the letters that, sir, this is the very proud moment of the Italy, and and my family want to see that proud moment when I will be receiving the Nobel Prize. And up now Mussolini agreed, because that was that will be the geopolitical praise of the Mussolini at that time. Yes, Italy got the Nobel Prize, and Mussolini was so kind, so kind-hearted and so brave-hearted. He sent the family of the Fermi. Okay, Fermi got the Nobel Prize in 1938. With the Nobel Prize, they also give the Nobel money. But what was the plan? And this was the perfect plan to save the family of the Fermi. Fermi went to receive the Nobel Prize with his wife Laura and his children, but he never came back Italy. He took the ship and he went to the America. No, you know one thing. Before even that, before receiving the Nobel Prize, Fermi applied in the American university, and Cambridge gave him the position. Cambridge gave him the job. Not only Cambridge, 5 American universities gave him the job. So this is the system of America. They welcome the talent with open heart, with open arms. बस उनको चाहिए कहीं से भी सारा talent बस अमेरिका आ जाए. So Fermi got the job. When he got the job, he went to the USA. He never came back to Italy. Because of the fascist law, of the Italy, the biggest nuclear scientist of the Italy went to the USA. And this thing USA could never have get using the war, using the hard tactics, because of the faults of the Mussolini, because of the anti-Jews laws. Fermi went to USA. This is one. Wait for a second. Now, in the Germany, there was the team of Otto Hahn and Lise Meitner. Otto Hahn, he is a German. And Meitner, she is an Austrian scientist. And they used to work in the lab of the Berlin. Now what happened? Hitler attacked on Austria. When Hitler attacked on Austria, this Meitner, being the citizen of the Austria, she lost all the immunity. Up now, and she is also a Jew. Now they were planning to arrest the Meitner by the German soldiers. So in the event, so these people planned that somehow let's do one thing. We smuggle Lise Meitner to the Nordic countries, because those Nordic countries were neutral. So the plan worked. In the last day, she took only one briefcase of cloth or something, some 10 mark of the money. And in the last day, Otto Hahn, he was very good friend of the Meitner, because they were very good team. Hahn was very good chemist, Meitner was very good theoretical physicist. She could explain anything. So on the last day, Hahn gave his mother's ring to the Meitner, so that if there will be you have to give some bribe, then give that bribe to someone. But Meitner never gave that ring to anyone else. So अब 1938 में after studying the experiment of the Fermi, Hahn with his friend, he was doing the experiment. Now what experiment he was doing? He was hitting the uranium with the neutron, and they were getting two particles with the impossible mass. Now they were very confused. That how this can happen, because at that time no one assumed that there can be the breakage of the nucleus, that someone can break the nucleus. This was not assumed by anyone. And Hahn and his friend, he was getting confused a lot. So whatever the result he was getting, he wrote a letter to Meitner, Lise Meitner. Lise Meitner was a woman. And now Lise Meitner, she was in Sweden. He received the letter because she was very good theoretical physicist. She could have calculated the result that Hahn was getting. Now, she got the letter on the Christmas Eve, and on that day, one friend of the Meitner was visiting to Meitner. That was Otto Fritz, and Otto Fritz was also relative of the Meitner. Now they were in the winters of the Nordic countries, Denmark, खूब बर्फ पड़ रही है. Now in a fallen tree they were sitting and they were calculating the equations. The result Hahn was getting. She was calculating the equation, and for their surprise, when they calculated the equation, they thought about the water droplet model. Let me show you something. They thought about the water droplet. They thought about the water droplet model. मतलब कि when you hit something in the water drop, it elongates like this. It is elongating, and it elongated that much that it divided into the two parts. This was happening. This was their result that they were getting by the calculation. This result they were getting by the calculation. Now they were confused that what should we call this process. And Frisch also has this Otto Fritz. He also had the very good interest in the botany and zoology. So they knew one thing, that how these cells they divide. How these cells divide. Now these cells divide. How they divide? They use the fission. Like how amoeba divides, by the fission. So one of the greatest discovery, the name of the one of the greatest discovery of the physics came from the biology. They called it nuclear fission. Yes, this was the Lise Meitner. Because of her theory, we got to know about the nuclear fission. And if Lise Meitner would not have been there, then the discovery of fission would have taken some more time. No, what happened? And this Otto Fritz, he was the student of the Niels Bohr, and he was also on the Sweden on that day. He was about to take the ship. Then Lise Meitner sent the Fritz to go and tell the Bohr that we have discovered the nuclear fission, with Otto Hahn, who was sitting in the Berlin. Now Bohr was going to meet the Einstein in USA. Bohr took this news of the nuclear fission in USA. Then there was a person, Szilard. When Szilard saw this news that yes, there can be nuclear fission, then Szilard assumed. What Szilard assumed? Szilard assumed that if this is the possibility that one neutron can do the nuclear fission, then there will be chain reaction. When one neutron can do the nuclear fission, then there will be chain reaction. And with this chain reaction, Germany must be moving nuclear bomb. Then Szilard and Einstein wrote the letter to President Roosevelt, and from here the project Manhattan started. And this Otto Hahn, he got the Nobel Prize for the nuclear fission. He got the Nobel Prize for the nuclear fission in 1944 when he was in jail. He received the his Nobel Prize, the news of his Nobel Prize when he was in jail. He was jailed by the Allied countries. And Meitner, who did the theory of that fission, she never got the Nobel Prize, because at that time they never appreciated women in the science. So Meitner never got the Nobel Prize, and that was the one of the biggest fault of the Nobel Committee, and for that Nobel Committee have been criticized like hell, because this was not the disrespect of the Meitner. This was the disrespect of the Nobel Committee itself, that you could not recognize that. Okay. Now, Fermi की बात कर रहे थे, for which Fermi got the Nobel Prize. Fermi never made the trans-uranium element. He was splitting the nucleus into the two, and he never recognized it. Then Fermi accepted that I got the Nobel Prize for that discovery that I never done. Then this discovery was confirmed of the nuclear fission. Then Fermi calculated, actually he was, then Fermi said, actually I was doing the nuclear fission, and I was thinking that I made the transuranic element. Now what we can understand with this story? Now the takeaway of this story is that you see these scientists, Fermi, he fled from the Italy. He went to the America. Then obviously Einstein, he was German. He went to America because of the persecution of the Jews. Then we have Szilard. Szilard, he was Hungarian. And he conceived the chain reaction. He wrote the letter to Roosevelt with the Einstein. That is why Manhattan Project started. And then Edward Taylor, after the fission bomb, he made the fusion bomb. He was also Hungarian. Then we have von Neumann. Von Neumann gave that von Neumann bottleneck, and even he made the computer for the calculation of the bomb. He was also Hungarian. Then Wigner helped the Fermi to build the first nuclear reactor of the world. That Fermi made in the Cambridge. He was also Hungarian Jewish. Then Meitner, Austrian, that discovered the Lise Meitner, the women that discovered the nuclear fission. Now, because of these refugees, what Germany and Italy lost, because of this fascism, because of the persecution of the fascism, American got the greatest scientific gift of the century. And these people were involved in the making of the nuclear weapon, except the Meitner. Meitner also got the offer for the Manhattan Project, but Meitner refused. Meitner said that I don't have anything to do with the bomb. No, I am not going to join your Manhattan Project. Science is my work, I did my science. And this was one of the biggest brain drain. That is why in the starting I said that brain drain can be threat to the national security. And in India, we are facing the problem of the brain drain. And Manhattan Project was what? Manhattan Project was the weaponization of the brain drain. Now, what we can learn from this historic brain drain, what India can learn? Homi Jahangir Baba, he was also in Cambridge. Then Vikram Sarabhai Patel, he was also in Cambridge. These people came back. They thought that if we have to retain our talent, we have to retain our Indian talent in India, then we have to build the institutions, and they started building the institution. Baba established TIFR, then Bark. He also coined 3-stage nuclear power program. Mr. Vikram Sarabhai Patel, he became the father of the Indian space program. He established ISRO. Now, what lesson we can learn, how we can retain our talent in India? The first thing that we need the research infrastructure, world-class research infrastructure we need. Then we need intellectual freedom, that our scientists, they can question anything, they can publish anything without the fear of fail, because in the science you will be failed many times, and without the fear of the political pressure. Then we must have the reward and recognition. So whatever scientist is getting in USA, can we give that much of the salary? No. Then there should be something equivalent, some prestige, some recognition, some influence he must have. Then only we will be able to retain the talent. Now what China did? Let us see what China did. China had a program. 1000 talent program. China started a program, 1000 talent program. Now this program have changed into the lakhs. Because of this 1000 talent program, most of the Chinese people who were good in the science, they came back to the China. When they came back to the China, what happened? Before this 1000 talent program, China was technology importer, and nowadays you can see China is technology rival. In AI, they are approximately developing together. In nanotechnology, China have 43% of the patent. In quantum technology, China have surpassed the leader, that is USA. China also has the 5th generation aircraft. China is building 6th generation aircraft. So China have become the technology rival. Now, abhi tak to right now TSMC is making 3 nanometer chip. Now China, their Alibaba, their Baidu, they are also trying to develop 3 nanometer chip. So nowadays, because they stopped their brain drain and they did the brain gain, their talent came back to their country, and because of which they became the technology rival of the USA. Now what in India we are doing? We have the PM Research Fellowship, we have the expansion of the IIT and IISc, we have the National Research Foundation. Now what else we need to do to retain our talent, to retain our people? That you can tell me. Now there are certain quotes that you can use in the essay, or these quotes can be asked. Hitler lost the war partial because of the expelled scientist. Same challenge India hai. A nation's greatest resource, its people's mind. People's mind gaya, Manhattan Project ban gaya. Knowledge has no password. Inclusion is not the clarity. Inclusion is not the charity. It is the strategy. लाइस मैटेनर के साथ आपने क्या किया? आपने इंक्लूड किया लाइस मैटेनर को इन द नोबेल प्राइज? नो. Institutional quality determines whether the talent stays or leave. If you will develop your institution, then only your talent will stay here. Otherwise, why the talent will stay here? Now, this was the part of the essay and the science. Now we will see something about the nuclear fission. Actually, what happens in the nuclear fission? There will be a slow neutron, और इसी को हम बोलते हैं थर्मल न्यूट्रॉन. This thermal neutron will hit into the uranium-235, and this uranium-235 is fissile. When it hit into the uranium-235, there will be chaos in the nucleus, like the water droplet model I told you. There will be increased tension, and this will divide into the two parts. That one will be barium, another will be krypton, and there will be two or three neutrons. Like this, there will be 2 or 3 neutrons plus approximately 200 mega electron volt of the energy will be released. Now, what we will do with this 200 mega electron volt of the energy? Let us see. With this heat, we will boil the water. पानी गर्म करके क्या करेंगे? चाय बनाएंगे? नहीं. We will boil this water in the nuclear reactor. When we will be boiling this water, it will convert into the steam. Then we will rotate our turbines. And there is a statement, when turbine moves, economy moves. कैसे economy move करेगी? When we will move the turbine, we will have the electricity. Cheap and reliable, because this nuclear reactor will work 24/7. It will not wait for the sun to come, for the wind to come. We will get reliable, cheap and reliable electricity. When this electricity will be cheap and reliable, then what will happen? Our manufacturing cost will decrease. When our manufacturing cost will decrease, then our goods will be more competitive. Our goods will be more competitive in the international market. Firstly, when manufacturing will increase, GDP will increase. And now see the outside of the India, our goods will be more competitive because now the cost is less. When our goods will be more competitive, then we will have the more forex. Then we will have the more forex. Now we will have more forex. We will have more money, and this money will come back to the country. And with this money and this increased GDP, what will happen? Here again we will be able to invest in research and development, more research and more development. When we will be able to invest in more research and development, then what will happen? Then we will be able to innovate more. When we will be able to innovate more, then cost of everything will decline, and this will be the good cycle. And ultimately what will happen? The quality of life of the people will increase. This is the ultimate aim of everyone. Everyone want to increase the quality of the life. Now you can also connect with Developed India 2047. Here innovation is increased, cost decreased. Now when you will do the more innovation, and none of the countries till the date have become the developed without doing the innovation. Now connect it with Developed India 2047 vision. Now you are doing the more innovation, again more GDP, again more each and everything, again more saving, and now you are giving the technology to others. When you are giving the technology to the others, and when you are giving the defense equipments to others, and other technologies like AI, like quantum, each and everything, supercomputer, सब कुछ you are giving to, सब कुछ you are exporting to other countries, and you will become included with the Vishwa Guru, the aim of the government. So this is how we can make the chart, and we can fit this chart anywhere in any economic activity. हमने स्टार्ट किया कहाँ से? ह्यूज एनर्जी से. जरा सी हीट मिली and we started this chart, and this is how we should write on the mains, and this chart will give you very good marks, and we can connect this chart with many other things, but अभी के लिए न्यूक्लियर टेक्नोलॉजी पे रहते हैं. then we splitted the nucleus. Now, after the splitting of the nucleus, we need to know about the chain reaction. When 2 or 3 neutrons will be released, these 2 or 3 neutrons, they will break another 2 nucleus, then another neutrons will be released, and this is how the chain reaction will be started. When one atom broke, 3 neutron released, then they broke the 3 atoms, then 9 neutron released, then 27, and so on. This will be the chain reaction. Now, if this chain reaction is controlled, it means we are absorbing some of the neutrons. We are not letting another neutrons to split the nucleus. We absorb these extra neutrons. Now there are only 6 neutrons. Now only 6 neutrons will be able to split the 6 nucleus. Next time we will absorb all other neutrons except the 6 neutrons. This is called the controlled chain reaction. And we use the controlled chain reaction in the nuclear reactor for the purpose of the power supply. And if we are not going to absorb these neutrons, then this chain reaction will be uncontrolled, and uncontrolled chain reaction is used in the explosive, is used in the nuclear weapon. The little boy and the fat man that USA dropped in the Japan. So this is controlled and uncontrolled chain reaction. Now from where we get the energy? Einstein never thought that my equation will become relevant for the nuclear energy. Einstein never thought when he was writing his equation. Now, when we splitted uranium-235 in barium and krypton, so the mass of this uranium-235, will always greater than the mass of the barium and krypton and the neutron that was released. It means some mass went missing, and this mass went where? As per the E equal to delta mc square. It means change in the mass. C is the speed of light. This missing mass, whatever mass was missing, this missing mass will convert into the energy as per E equal to delta mc square, and this energy will be very huge. For one atom of the uranium-235, this energy is 200 million electron volts. Now fissile and fertile isotopes. Fissile isotopes will be those isotopes which will, when we will stuck this fissile isotope like plutonium-239, like uranium-233 or uranium-235. When we will stuck this fissile isotope with the thermal neutron, what will happen? It will break down. It will have the fission in krypton and barium. So plutonium-239, uranium-233 and uranium-235, they are the fissile. Then what are the fertiles? Fertile isotope, these fertile isotopes, they will not undergo fission, but they are fissionable. It means they will convert into the fissile isotope. Fertile will convert into the fissile, and fissile will undergo the fission. Now let us see how this process works. How fertile convert into the fissile. Now uranium-238, this is fertile. Thorium-232, this is fertile. They will not undergo fission. What will happen? What we will do? We will hit a neutron on the uranium-238. Now when we will hit the neutron on uranium-238, what will happen? It will become 92 uranium-239. This it will become. When it will become 92 uranium-239, then here the number of neutrons are hugely more. It will try to attain the stability. Then one neutron will convert into one proton. Now it will become now it will become 93 Neptunium 239. Again there will be beta decay, again there will be beta decay, and then it will become plutonium 239, or you can say 94 plutonium 239. And this is how we got the fissile plutonium. And Indian nuclear weapons are plutonium based. Then we have thorium, and we have the abundance of thorium in Indian coast and in also Chota Nagpur plateau. Then again we will stuck a neutron with the thorium. Then this thorium 90 thorium, it will become 90 thorium 233 because one neutron increased. It will undergo the beta decay. It will undergo the beta decay. When the beta decay will happen, one neutron will convert into one proton. It means now one proton will increase. It means atomic number will increase by the 1. When atomic number will increase by the 1, it will be a new element, and this element is the protoactinium 233. Again there will be one beta decay. Then protoactinium will convert into the uranium 233, and this uranium 233 is fissile. And this conversion of thorium into uranium 233 is the target of third stage of nuclear power program that was proposed by Mr. Homi Jahangir Bhabha. Now why we have to do this? Why we have to convert thorium into the uranium? Why we can't directly use the uranium 235? The uranium 235, that is fissile. Why we are doing the conversion? What is the need of the conversion? The reason behind it is that when we mine the uranium in the natural composition, uranium 235 that we get, it is only 0.3%, and this is fissile. जो हमें काम का है, the thing that is usable, that is very less in the nature. Then uranium 238, 0.7%, 99.3%. This is beta fertile. Firstly, we need to convert this fertile into the fissile, then only it will work. And the next problem, why we are using thorium in our third stage? Because we don't have uranium. We have approximately 25% of the reserve of the thorium in the world, but only 1 to 2% reserve of the uranium in the world. We have 17% population of the world, 2.4% of the area of the world, and only 1 to 2% uranium of the world. That is huge injustice, I think. That was done by the nature itself. Okay, there is fun fact that name of the uranium, the nomenclature of the uranium was done because before some time they discovered the planet Uranus. Same with the plutonium, they discovered the planet Pluto. Right now it is not the planet, right now it is the dwarf planet, but on the name of the Pluto they named the plutonium. On the Nordic god Thor, they named the thorium. And these are all the gods. Now why the nuclear energy? Because the energy density of the nuclear energy is so high. You can, here we have taken 100 watt of the bulb for the comparison, that if we are using wood, coal, diesel of 1 kg, then that 100 watt of the bulb we can light for 4 to 5 days. From the wood 1.5 day, from the coal and diesel till the 4-5 days. If we are taking the uranium, reactor grade uranium, that is only 5% enriched. Abhi aayega what is enriched. That is only 5% enriched. Then it can lit that bulb for 1300 years. And if we are taking uranium 235, 100% uranium 235, then it will lit the bulb for 26,000 years. That is huge. Thorium or plutonium, breeder reactor, voila. Then it will lit for 25,000 to 26,000 years. That is huge, I think, for 1 kg of that. So that is why our government is also focusing to increase the share of the nuclear energy in the energy mix, and there are some other various reasons. There are climatic reasons and strategic reasons that we will discuss later. Now, there is a process that is called uranium enrichment. Why we have to do the enrichment? Because 99.3% is uranium-238, that is fertile. That is fertile. Then we have only 0.7% uranium-235, that is fissile. Now, inside the reactor, to make this reaction of the fission, to make the fission more efficient, what we will do, we will increase the quantity of the uranium-235. That is called, increasing the quantity of the uranium-235 in the mix is called the uranium enrichment. And in the uranium enrichment, we will use the centrifuges, gas centrifuges. Inside the gas centrifuges, we will have the uranium hexafluoride gas, UF6 gas, and this centrifuge, we will rotate this centrifuge. What will happen? This uranium-235 is light. Then when it is light, it will move towards the center of the centrifuge, and uranium-238, this is heavy, and heavier parts or heavier elements or heavier isotopes, they will move towards the surface of the centrifuge, and here they will have one pipe. With that pipe, they will fetch that uranium-235, and this is how they will have thousands of the cylinder. The same process will be repeated by thousands of the time, and this is how they will enrich the uranium. In enrichment of the uranium, they are doing what? They are increasing the percentage of the uranium-235 in the mixer, so that we can have more fissile material, so that we can have more material, which will undergo the fission. So this is the process of uranium enrichment. Now, there are three terms: low enriched uranium, highly enriched uranium, and weapon grade uranium. In the low enriched uranium, the uranium enrichment of the uranium-235 will be up to 20%. Up to 20%. And here in the reactors, usually we use uranium that is enriched up to 4 to 5%. Then if the uranium is enriched more than 20%, suppose this is 20%, if the uranium is enriched more than 20%, this is not the weapon grade. Weapon grade uranium will be here if this uranium will be enriched more than 90%. Then what is this? 20% to 90%. We are going to develop the weapon if we are enriching the uranium above the 20%. And this uranium, highly enriched uranium that is enriched more than 20%, that will be used in the submarines. Like we have three nuclear submarines: INS Arihant, INS Arighat, INS Arihant, Arighat, Aridhaman. We have three nuclear submarines. These nuclear submarines are powered by the nuclear reactor. Now, in these nuclear submarines, we will use the highly enriched uranium, 40% enriched uranium, 50% enriched uranium. This uranium enrichment, 40%, 50%, this will be used in the reactor that we have put in the submarine for the generation of the electricity. When the electricity will be generating using the nuclear reactor in the submarine, now to burn the diesel, they don't have to snorkel, बाहर नहीं आना पड़ेगा उनको. मतलब इसको देखो ऐसे समझो, when we are using this nuclear submarine. In the diesel engine submarine, in the diesel electric submarine, what is the problem? Suppose this is a diesel electric submarine, and the combustion, any combustion will not happen in the absence of the oxygen. And in below side of the sea level, where submarines will be there, under the sea water, there will be no oxygen. When there will be no oxygen, how there will be combustion of diesel? When there will be no combustion of diesel, then how this diesel will generate electricity? No, it will not be able. Then this diesel submarine, they have to snorkel nearby the surface. They have to come to the surface for the combustion of the diesel, so that they can get the oxygen. Of what they do, they have this type of pipe. By this, they are getting the oxygen from the atmosphere, and they are doing the combustion of the diesel. And when they are doing the combustion of the diesel, then they will charge the battery, and after charging the battery, they will again go deep into the water, and after some time again they have to come towards the surface. So this is the process. This is how these diesel electric submarines will work. Now, for the nuclear submarines, they have the reactor for the generation of the electricity, and in the nuclear electricity generation, we don't need any oxygen, so they don't have to come to the surface. They can remain underwater for the years, like INS Arihant, INS Aridaman, INS Arighat we have. They can remain underwater for a very long time. They can remain underwater for a very long time. Like USA, as per the AUKUS agreement, USA is giving Virginia class submarines to Australia, and that Virginia class submarine will use 80% enriched uranium. And as per the USA, that Virginia class submarine, they don't have to come to the surface for 33 years. It does not mean that it will not come to the surface for 33 years, because in the submarine we will have the sailors, their supplies, and their many of their things will be needing to change, their repairs of the submarine. So it is not like that it will not come to the surface for 33 years. Yes, but if it want to remain underwater, it can remain for continuous 33 years. This is the power of the Virginia class submarine. And our INS Arihant and Arigat, they can also be underwater for a long time. Now, why we need these type of submarine? We have 3 nuclear submarine. China have 12 nuclear submarine. We have total submarine 17. China have approximately 67. And why we want this nuclear submarine? We want these nuclear submarine for the nuclear triad. Now, why we need the nuclear triad? Nuclear triad, it means when you have the capability to fire the nuclear weapon from surface, from air, and from water. Water means underwater. If you want to fire the nuclear weapon by land, you have the Agni missiles, you have the Prithvi missiles, now you have the Pralay Saurya also. If you want to fire the nuclear weapon by air, so you have this Rafale, you have Su-30 Mk1 Jaguar. In say you can fire the nuclear missile using the air. Then in the sea we will be using the nuclear submarine, which will be using the nuclear propulsion, and for that now we have 3. And these submarines, they don't have to come to the surface for very long period of the time, and these land based and air based missiles, they are vulnerable to the attack. They are vulnerable with the attack of the enemy. Enemy can target these sites, land sites. Enemy can target your fighter jets. But when enemy don't know that where is your submarine underwater, enemy don't know, and that submarine can hit nuclear weapon using some missiles that this submarine have, like these submarines will have K4 class ballistic missiles, K15 class, K15 Sagarika. K15 Sagarika have 750 kilometer of the range. K4 have 3500 kilometer of the range. So they can fire the nuclear weapon using these missiles, and this is the safest and most survival, because when enemy don't know what is the location of your nuclear submarine, how he will destroy you, and you can you can suddenly attack over the enemy, and you know for which enemy we are talking about here. There is only one enemy by which we can have that type of war. Can you answer me, eastern neighbor or western neighbor? Now, whatever we have discussed till the time, there is one more thing that I want to tell you before summing up. In the low enriched uranium, we can trade on the low enriched uranium under the inspection of the IAEA. In the IAEA, we have some protocols, like in the IAEA, this is tradable low enriched uranium under the inspection of the IAEA. IAEA means International Atomic Energy Agency. Now this IAEA, it have protocols. One is safeguard agreement, and another is additional protocol. With these protocols and agreements, IAEA do the safeguard of the trade of the fissile material. IAEA do the inspection of the trade of the fissile material or low enriched uranium up to enriched up to the 20%. Now, can someone trade highly enriched uranium? It is completely illegal. It is completely illegal to trade in the highly enriched uranium. Even under the inspection of the IAEA, it cannot be traded as per the NPT, as per the Nuclear Non-Proliferation Treaty. अभी इसकी बात करेंगे हम. In the next classes, we will talk about what is this additional protocol, what is this safeguard agreement. The safeguard same agreement is also known as the separation protocol. Separation protocol. So these things we will discuss in the next class. Now let us sum up the class. What we have learned. So there are certain things, certain keywords that we need to remember. First is your isotope. In the isotope, we will have the same number of the proton but different number of the neutron. The fission, it will split into two and it will release the energy. Chain reaction, neutron will trigger the chain reaction. Fissile, uranium-235, uranium-233, plutonium-239, they are the fissile and they will undergo fission. Fertile, uranium-238, thorium-232, they are fertile and they will convert into the fissile. Uranium-238 will convert into plutonium-239, thorium-232 will convert into the uranium-233. Then we have enrichment. In the enrichment, we will increase the percentage of the uranium in the mixer. Then we have the half-life. Half-life is the time for the 50% of the decay. Then we have alpha, beta, gamma decay. Alpha is a particle, doubly charged helium nucleus, and alpha decay we were using in the space probes like in the Voyager 1 and Voyager 2. Then beta decay, when a proton will convert into neutron, then we will have the beta plus decay, and beta plus decay we will use in the PET scan. Then beta minus decay, when the neutron will convert into the proton, then the element will be changed. Then gamma is just pure form of energy. When the gamma will be released, no new element will come into the form. Then RTG, in the RTG we will use the alpha decay, that is radioisotope thermoelectric generator, and this E equal to mc square, the famous equation of the relativity, was given by the Einstein, and this equation follow the rules of the conversion of mass into energy. So in the next class, what we will discuss, in the next class we will discuss about IAEA first thing, then we will discuss about separation protocol, third thing that we will discuss, that will be the additional protocol, then after discussing these protocols of IAEA, we will move towards the reactors. In the reactor, we will discuss the 3-stage nuclear power program, In this, we will discuss all the stages. First, uranium based. Here we will discuss the reactor, PWR, PHWR, then BWR. Second stage that we have just entered, we will discuss about the fast breeder reactor. Third stage, we will discuss advanced heavy water reactor. We will discuss molten salt reactor. We will discuss accelerated driven system. We will discuss compact high temperature reactor. These are many reactors we will discuss, and their applications, their strategic roles. All of these things we will discuss in the next class. So overall, I will take approximately 5 classes of the nuclear technology, and next technologies will come later. Thank you very much. If you have any question, you can always ask the question, and the notes that you will be getting on your portal. So if you have any question, you can ask. Okay, then thank you very much. Have a nice day.